Hey guys, we're starting Unit 4. This is Notes Part 1, and today we're going to learn about what ions are. And you may have heard of ions because ions make these things called ionic compounds. So ionic compounds are similar to molecules. We talked about molecules before. However, these don't make specific single units, and if you did, you would call them, so these are made of formula units, as opposed to before they were made of molecules, which would be, this is the lowest whole number ratio. And they are made of ions. So then, if we're saying that ionic compounds are made of ions, we need to describe what an ion is. So an ion is anything with a charge. So anything with a charge, and if we think back to what we learned about charges and our atoms, if you remember, our atom has a positive center from the protons and then has a negative outside from the electrons. So the charge comes from the ratio of protons to electrons. So protons are positive, electrons are negative. For an atom, the number of protons can't change because the protons are in the nucleus, and the nucleus doesn't change unless it's a nuclear reaction, as in like an atomic bomb or something like that, which we're not going to be doing in our chemistry class. What we can change, though, is the electrons. So these are going to determine your charge. All right, so there are two types of ions. The first is a cation, and this is an ion with a positive charge. So a positive charge comes from having more protons than electrons. These are generally going to be metals because metals tend to lose electrons. If we go to our periodic table here, we can see the metals, all these on the side. So remember, these are your metalloids, right? And anything to the left of it are going to be metals. So for example, magnesium looks like this on the periodic table. So an atom of magnesium has 12 protons and 12 electrons. But when it becomes an ion, it's actually going to lose 2 of those electrons. So when it's an ion, it's going to have 12 protons still, because that doesn't change, and 10 electrons. So we can see that magnesium, since it lost 2 electrons, it's got 2 more protons than electrons now. So magnesium, when it makes an ion, is going to be Mg2+. The way we can figure this out is because this is electrically like a noble gas. And if you remember in the past, we were saying for covalent bonds that things are going to bond up so they can be electrically like a noble gas, right? They're going to share to have a full shell. If you look at magnesium with its 12 electrons, if it loses 2, boom, boom, it bounces back to be like neon with 10. Let's draw out the electron configuration of magnesium to look at that. Magnesium, the atom, is 1s2, 2s2, 2p6, 3s2. When it loses those 2 electrons, it always loses valence electrons. Valence electrons are going to be the electrons that are lost. Those are the highest energy level electrons. So when these go away, and they're going to be picked up by something that attracts electrons, something that's more electronegative. Then it's going to become Mg2+, which is 1s2, 2s2, 2p6, no 3s2 now, which is electrically like neon. Now it's not actually an atom of neon because if you remember it still has 12 protons, but electrically it's like neon. Another way to look at it is magnesium has that positive 12 center, and then it's going to have 2 electrons here in the first energy level. It's going to have 8 electrons in the second energy level. That comes from the 2s2, 2p6. And then it's got 2 electrons in its outer energy level. So this is magnesium. Now this outer energy level isn't full, right? It's only got 2 of them. And whenever an atom is becoming an ion, it's got the choice of either filling up to get to a full octet or losing to go to the full shell underneath. So this has the option of fill up to 8 or drop all valence electrons. Since we have 2 valence electrons in the outer energy level, this would require gaining 6 electrons. If I were to drop all valence electrons, that would require losing 2 electrons. I would lose these 2. And if I'm an atom, I'm going to do whatever's easiest. It's easier for these 2 to go away and become Mg2+. So Mg2+ is going to have that positive 12, and then it's going to have 2 energy levels. So 1, 2, and then the 8. Your atom gets smaller whenever it becomes an ion because those positive 12 are only sucking in 10 electrons now as opposed to 12, so everything gets a little smaller, and this is how it is. So if you look on the outer energy level, we now have a full outer energy level. It's just now on energy level 2 as the outer energy level as opposed to 3. So all atoms have this choice to fill up to 8 or drop the valence electrons. Magnesium chooses to drop valence electrons because doing 2 things is easier than doing 6. The other type of ion we have is an anion. An anion is an ion with a negative charge. This happens when the protons are less than the electrons. These are generally going to be nonmetals because they like to gain electrons. A way to remember that is negative, so negative has an N and gain has an N, versus before this lose, and these are all positive. So lose, positive. If you lose electrons, you become positive. If you gain electrons, you become negative. So let's go back to our periodic table and remember where our nonmetals are. So these are our metalloids, right? So it's going to be to the right of it. It's all these green ones here. So let's say we're nitrogen, for example. So nitrogen has 7 total electrons. Okay, so as an atom, it's going to have 7 protons and 7 electrons. To become an ion, it's still going to have 7 protons. The number of protons does not change, but this is going to pick up electrons to have 10 electrons. And if you notice, we've got up to 10 again. Not all of them are going to be 10, but these examples are. This is now going to be still nitrogen, but you have more electrons, and I have 3 more electrons than protons. So it's going to be a 3 minus charge because each one of those electrons that have been gained have a negative charge to it. So it's a negative, if this was 7 to 8, that would be -1. If this was 7 to 9, it'd be -2, but at 7 to 10, I have 10 more, so it's a -3. And this is electrically like a noble gas, just like before. This is electrically like neon. If we were to do our electron configuration, nitrogen is 1s2, 2s2, 2p3. Okay, so this is a nitrogen atom. Now it's gaining 3 electrons, so the next 3 go to the last place you are filling. So nitrogen with a 3 minus charge is going to be 1s2, 2s2, and then it gained 3 electrons into its outer energy level. So instead of 2p3, I gained 3 more, so it's going to be 6. Okay, because the electrons always go into the p block for the valence shell. It's not going to go into the s block because the s block would always be full to get up to the nonmetals. So we've got 1s2, 2s2, 2p6, that's neon with a -3 charge. And if you'll notice, this is electrically like neon. Now they are not all electrically like neon, it's just I picked 2 that were kind of smaller atoms, so it was a little less for you to write, but the biggest thing is that they all become electrically like noble gases. So we're going to try and be like these guys, whatever it takes, gaining or losing, whatever's easiest to be like noble gases. The goal is to be electrically like noble gases. Now just like before, let's also draw out our atoms. So nitrogen has a +7 center. In the first energy level, it's got 1, 2. In the second energy level, it has 2 in S, 3 in P, so it's got 5. And it's got the same choice. Is it going to fill up to 8? Oh, we haven't made a choice yet. Fill up to 8, or drop all valence electrons. If we were to fill up to 8 on the outer energy level, so right now we have 5 in the outer energy level, to get up to 8, this would require gaining 3 electrons. Okay, because if I have 5, I would need to add 1, 2, 3 to be up to 8. If I were to drop all valence electrons, then that would be getting rid of all of these to go down to the next shell that's full. This would be losing 5 electrons. So if I'm an atom and I'm going to say which of these is easier to do, then it's easier to do 3 things than it is to do 5. So I'm going to fill up to get up to 8. So it's going to take electrons in from another atom and put them in these 3 spots. So when nitrogen becomes N3-, it's going to look like this. So I've still got my 7+, and then I've got my 1, 2 still in the first energy level. My ions, when I become negative, actually get bigger because there's more electron-electron repulsion. So when I'm putting more electrons in this outer energy level, they all push off each other and it spreads out a little more. So my negative ions, my anions, are always bigger than their neutral atoms. So this now has a full outer energy level. Now if you're going to pick the charge of whatever your atom is, here are the questions that you need to ask yourself. All right, so what charge will an atom make when becoming an ion? The first question you want to say is how many valence electrons does this atom have? Then you want to say, well, how many to fill up to 8? Or how many to lose all valence electrons? The second one, how many to lose all valence electrons, this is always going to be equal to your total number of valence electrons. Whichever of these is lower, that's the option you're going to go with. So if you only have to gain 1, for example, to get up to 8, you're going to choose that versus getting rid of 7. It's always whatever's easier to do. And then remember, gain makes your ion negative. If you gain electrons, because electrons are negative, and if you lose, then that's positive. Your ion's going to be positive. So gain is negative, lose is positive, and then the number is just however many this number was. All right, so good luck with the practice questions. I'll see you in office hours if you have any questions or if you want to go over some more examples. Otherwise, see you in the next set of notes.